I'm going to solve the question on the graph for the electricity, which I've just performed an experiment which I uploaded previously. And what I'm going to do now is, if you check the video at the last part of the video, you will see a table of value, current, a length and current, which are supposed to be plotted, and also have a column for L inverse, as you can see on the screen. What I'm going to do today is to plot a graph. And the graph I'm going to plot is going to be current against L inverse. As you can see on the board, this is current, I represents current, and L inverse represents length. So I'm going to show you how this graph can be plotted. And in my last video, somebody complained about what I did, that I missed some values. It is not by missing values. Look at the sign I made here. This sign represents that there are some values I have deemed unimportant, and there are some values that are not going to be captured in the graph. So I put this, and that represents what we call cake. This is the value. This thing means that there are some values that are not captured by graph in order for the space of the graph to be accommodated in this one. For you to be able to understand this graph very well, you first of all have to find what each of these lines means. All these small lines, this line, this line, this line. Each of them should represent a value, which, being able to know what they are, watch what is on your screen. If you watch what is on your screen, you can have things like 0.65 and the 0.011, 0.68 and 0.13 and so on and so forth, as you see it there on the screen. So what you are going to do now is, the question should now be, okay, before we go into that, let's first of all write the scale that we have chosen. You are going to say that 0.05 is equal to, 2 centimeters for the vertical axis. And then 0.005 represents 2 centimeters on the horizontal axis. Now, if you know this, the question you should ask yourself is, what should be the value for each of these lines for the horizontal axis? Each of these, one line, this line, what do they represent? And then, what is it represented on this vertical axis? Okay, so listen, what I want you to know is this. If 10 lines represent 0.005, then one line is going to represent 0.0005. That means 0.005 divided by 10. Okay, like on the horizontal axis, I made it 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each line represents 0.005. So we are moving on. Then on the vertical axis, I'm going to say that 0.05 divided by 5, 0.01 for each line. Each of these lines, this one is 0.005, 0.005, 0.005, 0.005. If you add 0.005 in 10 places, you will get 0.005. If you add 0.000, 3 zeros and 5 in times 10, you get 0.2 zeros and 5. That is what you are going to get on the horizontal axis. But coming to this vertical axis, if you say 0.01, times 5, you have 0.00. Okay, let's do 0.01 times 5. You have 0.05. So, and that is what from here to here represents 0.05. Sure you understand? If you still don't understand, you make a comment below. I'm going to be responding to you. Now, what I'm going to do here is this. I am going to be saying that 65, this is 65. Where does it correspond? This is 0.0, this is 0.01. Now, I want to get 0.011. So what I'm going to do is, this is 0.1, this is 0.01. I'm going to be adding 0.005. If I add it, I keep adding on this to see if I can get 0.01. Now let's say 0.01 plus 0.0005. It's not this, what you have is 0.0105. Use calculator and work with me. Then if you add another one, 0.0005, you have 0.011. That means after this first one, the second one is where this second one is what is this second line is where the 0.011 corresponds. Therefore, I'm going to go from this part to allocate where it is with this 0.6. The first one is not, is the second one that will correspond to this. So the next thing I'm going to plot is 0.13. Where can I locate 0.13? And if you check 0.0005 times 6 plus 0.01 will give you, so that means it's the sixth line. 1, 2, 3, 4, 5, 6. This is the sixth line. So let's check. 0.0005 times 6 is that, then plus 0.01. That is, you are going to have 0.013. Now that means it is on the sixth line. I'm going to trace the sixth line, and the sixth line corresponds to 0.68. Now the question should be, how do you get 0.68 here? You have 0.65, and the next one is 0.7. Now how do you get 0.68? Now remember this one, what we have already gotten that this is the line that corresponds, this place is 0.013, is on the sixth line. Now what we are going to do, remember on this vertical axis, what you have is 0.01 for each line. Now we're going to say 0.01 times how many will give us, plus this 0.65 will give us 0.68. I'm thinking it's 3, 0.01 times 3, then plus 0.65. It's 3 lines. So you are going to count, this is the first line, second, third. So this third line, you keep pressing it until you meet the sixth line. That is it. Now, the next one is 70. 0.7 is the same thing as 0.70, so 0 should be here, 0 should be here. 0.70 is not 0.70, 0.70. Then I'm looking for where it corresponds with 0.14. This is 0.013. I'm looking for 0.014. I'm sure it's going to be on the 8th line. So this 8th line is here. How did I get it? It corresponds to 8th line. What we are going to do is use 0.0005 times 8. Whatever you get, add it to this, because it is from here that we try to get this. This is the 8th line. This is 1, 2, 3, 4, 5, 6, 7, 8. This is where it is. So to get it, if you say 0.this line times 8, adding it, then the next thing you're going to do is 0.17. This is 0.17 cannot fall between here and here. This is 0.15. So we are looking for 0.17 somewhere here. So 0.17, okay, let's say 0.0005 times 3. Then plus 0.015. It's not up to. So 3 lines is not up to. Let's add plus 0.0005. 0.17 is 4 lines. If you say this plus this plus this, remember I told you that each line here represents this 0.0005. So that is what each line represents. So on the 4th line, that is why you get 72. Now, how do we get 0.72? So at this point, 1, 2, 3, 4. 1, 2, 3, 4. This is the point. So how am I going to trace it to get 72? Coming to this place, 0.70, 0.71, 0.72 is at this point. So we keep tracing to this point. This is the point here. Now, I am plotting the next one, which is the next one after 0.7. We have 0.02. 0.02 is already here, nothing to struggle for. And 0.7 is already here, nothing to struggle for. So the two of them coincide at this point. So if I put it this way, you see, I'm going to be having this. So what happened to this? If this thing is not well distributed along the line, should I go this way? Yes. This is my best line of fit. This is my line of best fit. I will show you why I said it's my line of best fit. It's my line of best fit in the sense that, see, this one fall out here, this enter, this one fall out, this enter, and this enters. And I'm looking at least 3 points entry, and then distributing this one fall here, the other one balances it by falling to the other part of the line. So this line is equally distributed amongst the lines. So now I have to plot my slope. How do I do my slope? I will look for any line, any point. I'll look for any point that enters on this graph. This point is well entered. This point is well entered. So I'm I'm using this point. It entered the line. Okay, I'm using this one too. I'm using this one. This one also entered. So I'm going to use those 2 points and join and form a triangle. So I'm going to join this line. So I have formed my right angle triangle, points A, B, and C. So I have to now do the needful by saying from here, from this point of B, you trace it to the vertical axis and collect the point at that point, and this is 0.8. I'm going to say 0.80 minus. You also trace this point. 0.72 all over this one. Where did it get to? This is 0.025. If I now have 0.025, after this line you have the next one, and this line, each of this line represents 0.0005. So I'm going to say 0.025 or 0.0005. And I'm going to have 0.0255 minus. Then this is another one, 0.015. Is 0.017. So it's 0.017. So if you look at the slope, but this is not mass graph, this is physics graph. Physics graph in the sense that on the vertical axis what I've plotted is I, I'm not plotting y, I'm plotting I. So it's going to be I2 minus I1 all over. What am I plotting on the horizontal? I'm plotting L inverse. So it's going to be L inverse 2 minus L inverse 1. It's the same thing. So this formula is that I'm just modeling this formula from here, model it to be here, based on what I have on the vertical axis and what I have on the horizontal axis, which correspond to y and x axis. And that is how I got these values. My slope. My slope is 10. Now, so 10, what is the vertical axis? Current. I'm going to write A. Then what do I have on the horizontal axis? Cm inverse. This is my slope. Now, there is something that you may ask you to find the intercept on the horizontal axis. So, and thank you for being part of this class. Remember, you have to subscribe, like, and share with your friends. If there is any concern here, please comment on the comment button and I'll be responding to you. Thank you and remain blessed.